We have been discussing the defects in crystalline solids, and we classified them on the basis of dimensionality, and we discussed 0 dimensional defect, which was vacancy or interstitial. We also discussed 1 dimensional defects, which were the dislocations, and we spent quite a bit of time on dislocations. Now, the time has come to discuss 2 dimensional defects in crystal, and these are surfaces or interfaces. These also play a very important role in determining the properties of crystalline solids, and we will spend some time on discussing surfaces and interfaces. So, let us first have a classification of surfaces and interfaces in a crystalline solid. So, I will give you a classification scheme. Surfaces or interfaces. So, initially let us divide them into homophage interfaces or heterophase interfaces. As the name suggests, homophage means they will be across the interface, same phage will be there. Whereas in heterophage, across the interface different phages will be present. So, for example, the free surface of the solid is an example of a heterophase interface. Because on one side you have a solid, so free surface, or external surface, so one side you have solid and another side you have gas or vacuum. So, it is a solid gas interface. So, it is a kind of heterophase interface, because across the interface you have on one side a solid, another side gas. Another example, important example of heterophase interface is a solid liquid interface, very important in casting. So, we have a solid liquid interface, and we can also have a solid heterophase interface, in which one side we have crystal 1 and another side you may have another crystal 2. Sometimes this kind of interfaces can also be called interphage, because you have 2 different phages, interphase interface. So, it is an interface across which you have 2 different crystalline phage. So, for example, on one side one can have a body centered cubic structure, on another side one can have a face centered cubic structure. So, that will give us an interphage interface. So, interphage interface, solid liquid interface, an external surface of a crystal, in which one side you have a crystalline solid and another side you have gas, all are example of heterophage interfaces. But another important class of interfaces in the crystalline solid is homophase interface, in which on both sides you have the same phage. Still there is some difference on the 2 sides, and that is why you create an interface there. So, in this kind of interfaces, one of the important class is what is called grain boundary. Then you have twin boundary, and you also have stacking faults. All these are special kind of boundaries, and across these boundaries the phase or the crystal structure does not change. What changes? In the case of grain boundary, the orientation changes, and this is a rotation type. So, one side, the crystal on one side of the boundary is rotated with respect to the crystal on other side. In the twin boundary, it is a reflection boundary. The crystal on one side appears to be reflected or a mirror image of the crystal on other side, and the stacking fault is a translation boundary. So, the orientation of the two crystals on either side of the stacking fault is the same, but still there is not perfect matching, because on one side the crystal is translated with respect to the other side. So, that causes a stacking mismatch or a stacking fault. Grain boundary can further be classified by, there are two ways of classifying. So, on one way we can talk of a low angle boundary. If the rotation angle is small, we call it a low angle boundary, or if the rotation angle is large, we call it high angle boundary. Usually less than, this is a low angle high angle classification, of course, is a rough classification. So, maybe let us say less than 5 degree we can call it low angle boundary, and higher than 5 degree we can call it high angle boundary. Another classification scheme is to classify them as tilt and twist boundary. So, one kind of boundary can be called a tilt boundary, another kind of boundary can be called a twist boundary. So, we will have something to say about all these boundaries in the subsequent lectures. So, we will discuss, in particular we will begin with the discussion of the free surface or external surface of the crystal is an important one, and then we will also discuss on grain boundaries and twin boundaries, stacking fault. So, these are the topics which we are going to discuss in the coming videos.